Hello everyone. We're discussing radioactivity and we have developed n equals to n naught e to the power minus lambda t, and we've also developed t half-life as ln2 divided by lambda. Half-life, decay constant, number of active nucleides initially at t equals to 0, number of active nucleides at any time t. And then I had asked you to get me n as a function of half-life. That's what I wanted from you. N in terms of t half. Is there anyone who has got this value? Look at this. This is n naught e to the power minus of lambda. What is lambda? Lambda is ln2 divided by t half. ln2 divided by t half. This is lambda, and you also have the term of t. That's your t. n naught e to the power minus, this is lambda log 2 divided by t half multiplied by t. Now we can rearrange this in this form: n naught e to the power minus of log 2 to the power, let's take the negative sign also inside. Let's remove the negative sign. We'll take the negative sign, also shift the whole thing in terms of power. This is ln2 to the power minus of t upon t half. Property of log. You can convert this whole thing as power of 2. That's what we have done. 2 to the power minus t upon t half. You can bring this whole part in front as a coefficient, giving you this. Now, once you arrive at this point, this is n naught e to the power log, what is ln? Ln means base is e, 2 to the power minus t upon t half. N naught multiplied by e, log 2 is log base e, 2 minus t upon t half. I had given you a hint that if you ever see something like this, a to the power log b a, then the whole thing is simply what? B. The simple property of log. Log means power. So a to the power log b base a is simply b. This is e to the power log e. So forget about e, log, and this e. You only get what? N naught 2 to the power minus of t upon t half. E log E. These things are gone. A log A, things are gone. You're left with B only. So this is N, which is coming N naught whole divided by, this is negative power, 2 to the power T upon T half. This is symbol of half-life, T half. 2 to the power T upon T half will give you number of active nucleides at any time T. Put down this much. Now, this is the relation between N naught time T half. Try to answer a very easy question. We have a parent nucleide A. After disintegration, it converts itself into B, daughter nucleide. Parent, daughter, after disintegration. It is given that at T equals to 0, A is N naught, B is 0. In a given sample, only A is present, B is not present. You need to find ratio of A and B after 3 half-lives. Find the ratio of A and B after 3 half-lives. Write down the question. In a given radioactive sample, initially only parent nucleide A is present. Find out ratio of A and B, parent and daughter nucleides, after 3 half-lives. Should not take more than 20-30 seconds. Look here. Let's make a chart. Time, concentration of A, of B, ratio. 20 is 0, A is N naught, B is not present. So the ratio is coming N naught upon 0. You can call it infinite. It's not defined. We are not interested in that part. After 1 half-life, T half. Half-life means this N naught becomes N naught by 2. So if it becomes N naught by 2, then it converts itself into what? B. So how many molecules of B are now present? N naught by 2. There are, let's say, 100 atoms or molecules. These 100 atoms now disintegrate. Becomes what? This 100 becomes 50. Rest 50. They become what? Daughter nuclide B. So what is the ratio right now? N naught by 2, N naught by 2, which is coming 1. Well, I gave you sufficient time to develop a chart like this. Although there is no need for a chart, but I am giving you another 30 seconds. Complete the chart and get me the ratio. This is after 1 half-life. I'm asking you what is the ratio of A and B after 3 half-lives. Let's see if you can answer correctly the whole thing. After 1 half-life, after 2 half-lives, it becomes N naught by 4. This was 100, becomes 50, and then it becomes what? 25. So what happens to other 25? Other 25, they become what? B. So this place will be what? N naught by 4 plus already present N naught by 2. These are 50, they become what? 25. And then other 25s, they increase concentration of B. After 3 half-lives, this becomes N naught by 8. These are N naught by 4. Become what? N naught by 8. This is your N naught by 8. Other N naught by 8. So this is 100, 50, 25, let's say 12.5, just for the time being. You are adding this, there were 25 atoms, now there are 12.5, other 12.5, they become what? B. This is coming 3 N naught by 4. So if you go for the ratio of A and B, the ratio is coming 1 by 3. What about this? This is coming 7 N naught by 8. Add all these and you get what? 7 N naught by 8. What is the ratio coming? 1:7. So this was a crude way of answering this question, forming a chart and then solving everything. What you could have done is this. At any time, if you look for A plus B, then it should remain what? N naught. Total number of nucleides, they are not changing. This is 100, this is 0. So at all times, you must have only 100 nucleides of A and B together. So after 1 half-life, you've got 50 of A. They are also what? 50. Total sum is coming again what? N naught. This is N naught by 4. This is 3 N naught by 4. Sum is coming what? N naught. Sum is coming what? N naught. That means we can use this formula and say this N A. We are calculating all these values after 3 half-lives, remember now. So this will be N naught upon 2 to the power 3. T is what? T is 3T half. 3 half-lives means T is 3T half, which is what? N naught divided by 8. So this is N naught divided by 8. Let's say this is now T 3T half. So if time is 3T half, what we have found that A is N naught divided by 8. What about B? We know that total sum should remain N naught. That means B is N naught minus N naught divided by 8, or what? 7 N naught divided by 8. This is here 7 N naught divided by 8, and this gives us a ratio of 1:7. That's the answer. So by using this formula and remembering that total number of nucleides, that this number is not going to change, you can answer the whole thing in just 20-30 seconds. Note down everything. Now answer this question. Half-life of a radioactive sample is 10 minutes. Half-life of a radioactive sample is 10 minutes. After what time ratio of A and B will be 1/31. Half-life of a radioactive sample is 10 minutes. If nothing is given, then it means that initially only parent nucleide is present. The question is, after what time ratio of parent and daughter nucleides will be 1:31. Let's see how many of you will answer this. Good. Very good. Others, take the hint. Look at this number 3. What is 3? 4 minus 1. What is 7? 8 minus 1. What is 1? 1 is 1/1. And what is 1? 2 minus 1. 4 minus 1. 8 minus 1. This is the hint. And with the help of this hint, try to answer the question. Look here. A, B, when T is 0, only A is present. When T is 0, only A is present. B is not present. At time T, any time T, how much A is present? This much. And not upon 2 to the power n. What is n? N is time in terms of half-lives. So if we say that, if I say this, at time t, there are n half-lives over, then this t means what? N times t half. You can continue with t upon t half also, doesn't matter. But it will be easier to represent whole thing in this form. So if I say that for this particular sample, if I say 20 minutes, 20 minutes will be what? 2 t halves. If I say 30 minutes, that will be 3 t halves. 30 minutes will be 3 t halves. 40 minutes, 4 t halves. So at time t, there are n half-lives over, then this t upon t half is what? N. It will be easier to answer in this form. So if this is concentration of A at time t, then what about B? Total sum should always be what? N naught. So this gives us N naught minus N naught divided by 2 to the power n. This is N naught 2 to the power n minus 1 whole divided by 2 to the power n. Now we are interested in what? A is to B. This ratio of A and B therefore is what? 2n cancelled, n naught cancelled, and your ratio is coming 1 upon 2 to the power n minus 1. This is the ratio. This is the hint which I gave you. After one half-life, n is 1. 2 to the power 1, 2. 2 minus 1, 1. After two half-lives, so after two half-lives means 2 to the power 2, which is 4. 4 minus 1, 3. 3. After three half-lives, 2 to the power 3, 8. 8 minus 1, 7. Now the question which I asked you is, after what time ratio will be 31? What is 31? 31 is 32 minus 1. So if 31 is 32 minus 1, let me answer this way. For this, 31 is simply what? 32 minus 1. What is 32? 32 is 2 to the power 5 minus 1, which gives us n as what? 5. So how many half-lives are there? 5. After 5 half-lives, what will be the time? 5 into 10, which is 50 minutes. So with this, if you remember this type of format, 1 upon 2 to the power n minus 1, which you can also directly observe, 3 is 4 minus 1, which is 2 to the power 2. 7 is 8 minus 1, which is 2 to the power 3. You can answer a question like this in just 10 seconds. In just 10 seconds. How do I say in just 10 seconds? I'll prove. Well, you will help me in proving this. So tell me, after what time ratio of A and B will be 1 upon 127. After what time ratio of A and B will be 1 upon 127? So, if I ask you at what time ratio will be 1 upon 127, what is 127? 128 minus 1. What is 128? 2 to the power 7. 2 to the power 5 was what? 32. 6, 64, 7, 128. This and that. It immediately tells you that n is 7. There are 7 half-lives present in that time when ratio becomes 1 upon 127, and therefore answer is 7 into 10 minutes or 70 minutes. That's how you can answer these questions easily. Now, this is for mostly school, NEET and JEE. If they try to increase the level a bit, not very much, then the question can be asked in this form also. Let's see how many of you will answer this thing now. You need to find time when ratio of A and B becomes 1 upon 16. At what time ratio of A and B becomes 1 upon 16? Take T half as 10 minutes, same thing. One upon 16. If I had asked you 1 upon 15, then it will just take 5 seconds. 1 upon 15 will be what? 16 minus 1. If I write 15, that will be what? 16 minus 1. 16 is what? 2 to the power 4. So you've got 4 half-lives. Answer would be simply 40 minutes. But look, I'm asking you at what time ratio is 1 is to 16. Let's see how many of you can answer this. Look here. How can you answer something like this? Ratio of A and B, question says is what? 1 upon 16. No issue. It only means that 2 to the power n minus 1 is what? 16. That means 2 to the power n is coming 17. If 2 to the power n is 17, then you need to find n, a power which should be raised over 2 so that you get 17. There is no integer power like 2, 4, 6, 7. So how do you find this n? Take the log. So if I take the log, it becomes what? Log 2n. You can take the log with base e, doesn't matter, because you'll be taking log at this place also, which is log 17 base e. You can take the log with base 10 or base e, it doesn't matter, because both places you are using log. This gives us n as what? Remember, the way I have taken log, once I take the log, I can shift the power as what? Coefficient. This is your coefficient n. This gives us n as ln of 17 divided by ln of 2. That's your n. What is t? T is n times t half ln 17 divided by ln 2 multiplied by 10 minutes. That's the time. So now any question of ratio type can be answered using this result. Do you understand this procedure, this process of using log? Are you comfortable with this? Yes or no? Write down in the comment box. Write down next question. Initially, that is at t equals to 0. Initially, a sample has equal number of parent and daughter nucleides. Initially, a radioactive sample has equal number of parent and daughter nucleides. Find out ratio of A and B. Find out ratio of A and B after 2 half-lives. Initially, your radioactive sample has equal number of A and B. Question is, you need to find ratio of A and B, their concentrations after 2 half-lives. Let's see if you can answer this. Very good. That's the correct answer. Good. All others. This is the very first question which I asked you. A, B, A is to B. T, 0. Not about this question. T0, this is N naught, this is 0. There is no meaning of A and B. T half, 1 half life, N naught by 2, N naught by 2, ratio was 1, 2 T halves, ratio was 2 T halves, 2 T halves, 2 to the power 4 minus 1, 2 to the power 2 minus 1, 3 T halves, ratio was coming 1 upon 7, 2 to the power 3, 8 minus 1. So this was the very first question which I asked you, that after 3 half-lives, what will be the ratio of A and B? And the answer was 1:7. Now the question I asked you is, at T0, both A and B have same concentration. So what you can say is, for some other observer, time, let's say T dash, starts from this moment. He says that this is 0. Why? If you reset your watch after first half-life, then it starts with 0, and what do you observe? You observe that A and B have equal numbers. The question says what? Question says after 2 half-lives. So from this moment, this is T half, this is 2T half. So for this second observer, this moment is what? After 2 half-lives. For the first observer, this moment is after 3 half-lives. So what will be the answer? Answer is what? 1 upon 7. So it's not necessary that A and B must have, only A should be present, B should not be present. You can always reset your question in this form. Let me again explain the whole thing. For some observer, let's say observer 1, time starts in the form of T, and this is 0. For observer 2, when he counts time, he uses T dash. After T half time, for the first observer, this second observer starts his watch. So for him, this is 0. For him, this is T half. For him, this is 1 T half. But for him, this is 2 T halves. We have already found if initially only A is present and B is not present, then I can use this formula. Remember, we can use this formula only if initially A is present and B is not. So, we have converted question asked for observer 2 into a question which is being asked for observer 1 by using this trick. Are you comfortable with this approach? Yes or no? Answer is 1:7. Now answer this. At T0, A is to B is, at T equals 0, A is to B is 2:1 initially. A is to B is 2:1. Then after 2 T halves, find out A is to B. This time initially A is to B is 2. After 2 half-lives, what will be the ratio of A is to B? Look, A is to B 2 is not present in this chart. A is to B 1:1, which was in the previous question, is present, but A is to B of 2 is not present in this chart. Then how will you answer this? Let's see if you can. Look, how you can answer something like this. Question says when time is 0, at the very initial moment, concentration of A and B is what? 2:1. That means A is N0 and B is N0 by 2. So A is N0, B is N0 by 2. Automatically ratio of A and B is what? 2:1. Somehow these many B's are already present in the sample. Now, once you have this idea, after 1 T half, this N0 becomes what? n naught by 2. This n naught by 2 is already present and half n naught by 2 are coming from this side. So you add them together. After 2t halves, question is after 2t halves, this becomes what? N naught by 4. This becomes what? N naught by 4 plus n naught by 2 plus n naught by 2. Initially only A is present. No disintegration of B takes place. After one half-life, n naught becomes n naught by 2. Rest n naught by 2. They become what? Daughter nuclei B. After another half-life, this n naught by 2 becomes n naught by 4. Rest n naught by 4 become this. That's what the question is. So this is coming what? N naught plus n naught by 4 or 5 n naught by 4. How much A is present? N naught by 4. So what is the ratio? Ratio is coming 4 and 4 cancelled, 1:5. That's the answer. So it doesn't matter if B is present initially or not, you can always use this. If you don't want to form a chart for two half-lives, you could easily do this. If they increase the number of half-lives, use the formula. Keep this B as if it's not present. As if it's not present. Find out this part. Find out this part. And this part always follows what? This equation, this relation. So these n naught by 2, keep them aside, solve the question and finally add this much n naught by 2. So nothing special. For any time, for any type of sample, for any type of initial concentration, you can easily handle this. If you are comfortable with 1/5, then write down yes in the comment box and then you can leave. Thank you very much.